Hello everyone, Alvaro here. Just want to let y'all know that we've made a t-shirt to celebrate our 5-year anniversary. We'll have a link on the show notes if you want to get one. We're just selling them at cost. This is just for fun. But I wanted to let you know before the show starts. We'll probably mention it at the end, but just in case. Anyway, enjoy the show. Hello and welcome to the Unnamed Reverse Engineering Podcast. I'm your host, Alvaro, and with me today is...
Sultan Qasim Khan.
Welcome. We should have got over this, but we're going to roll with it. So Jen, my co-host, is here. And then our guest today...
I was just like, you really didn't lead up. So I'm just like, I'm not going to step on our guest's name. By the way, I just want to say that we're really doing well. We're basically our 61 episode streak of laughing at the intro continues. Oh, hey, also your co-host Jen Castillo is here.
So welcome, Sultan. We're really glad to have you here.
Don't let the giggles belie that.
We're a serious podcast. So the folks over at Hardware I/O conference connected us. And when I was looking at some of your background, it seems like you do tons of really cool stuff with Bluetooth and a few other things. But before we get to that, could you tell us a little bit about yourself and some of your background and how you ended up reverse engineering for a living, basically?
Sure. So I think my interest in these kind of things started when I was doing some software development, and I was porting a piece of software that interfaced with some 3D measurement cameras from Windows to Linux. And that software made use of some features in the FTDI D2XX library that were specific to the Windows version of the library. They had a Linux version of the library, but it was based on libUSB and a different code base that was just lacking a few functions in there. So I wanted to recreate those missing Windows-only functions in the Linux version of D2XX, and that led to me reverse engineering it and just need to figure out how the things worked at that level required me to learn so much about how software is put together and being able to work backwards rather than having access to the code. So I think that just spawned an interest in reverse engineering and low-level native code. And from that, just by becoming interested in the field, I became a little interested in security. And then when I had an opportunity to start working as an intern at the Motorola mobility security team at the time, that was a massive opportunity. And while I was over there, I was exposed to so many different aspects of the security field. I was also given a chance to do some research related to Bluetooth Low Energy. In particular, I was recreating some attacks that were theorized by Mike Ryan during some of his Ubertooth development. And so I added a whole bunch of different features to the Ubertooth firmware, maybe in a somewhat hacky manner circa 2014. And I think that got me hooked in the land of Bluetooth. So since then, I ended up becoming a consultant with NCC Group. Actually, much of the Motorola mobility team that I was with over there came over to NCC Group, and we ended up working with the same people. Yeah, it just through this, I've been exposed to so many different aspects of hardware and embedded system security, and that interest in Bluetooth that was cultivated from some early project as an intern there has become a key skill of mine.
That's really cool. So going back really quick, you mentioned you had some sort of 3D or stereo camera that you had to port or create drivers for Linux. What tools were you using back then? Did you have a USB analyzer? I know Wireshark these days you can use for packet analysis, or are we just looking at code and figuring out what it did that way?
I was purely through looking at code in that case. So
Wow.
at the time, I was an intern at that company building these cameras, but I didn't have any access to the FTDI code. We were just using the FTDI proprietary D2XX libraries and interfacing with that. So I could see how we were using the FTDI driver in the Windows side of things, but I didn't know what the FTDI driver was doing underneath, and so I had to reverse engineer the driver to recreate that functionality on the Linux equivalent that was using a completely different code base.
Oh, that's cool. So this is having to reverse engineer things just to get your work done. I think this is the most common type most people run into these days. There's like, hey, I have these tools. I just don't know how they work and I need to fix them.
Yep. Whenever you're dealing with proprietary software, it's hard to maintain compatibility in the future when you're dealing with systems that change and proprietary bits you can't change
just
directly
DLLs,
yourself.
right?
Mm-hmm.
And then you mentioned Motorola Mobility Lab. Was that kind of a Motorola security lab, or were you just doing engineering? What was that?
So we were the security team for the side of Motorola that was making phones. So at the time, that part of Motorola was acquired by Google, and that was the era when the original Moto G and the second gen Moto G and the Moto E, all those very successful products had come out around then. So our team was responsible mainly for bringing up of security-related features on these devices, as well as um, making sure that the boot chain was secure, features we were adding to these were secure, and dealing with security issues as they came up in these products. As an intern, my role was more just assisting the team and also researching things that others in the team did not have time to get into.
Yeah, that's what it. I mean, that sounds like a good internship, right? Because you get to actually do fun stuff.
Exactly.
And okay, and then you mentioned Mike Ryan, past guest of the show, multiple time guest of the show, and Ubertooth. So you were working with Ubertooth kind of on your own, just for fun, before you got started in all this, or?
So I was given some tasks to tinker with Bluetooth Low Energy, and at the time, so Mike Ryan was one of the main leading researchers in the Bluetooth LE space, and he had developed Ubertooth. And so it was an extremely capable hardware platform because of the flexibility of the radio, and it was the obvious platform to implement these attacks I was interested in because much of the existing Ubertooth firmware laid the groundwork for what I wanted to do, and I just built upon it.
Can you speak to some of these attacks you were implementing?
So at the time I was doing this, now this was many years ago, and it's a little fuzzy in the details.
No worries.
But at the time, I think in a paper that was published by Mike Ryan and a few others, they had theorized the attack where you could first discover an existing Bluetooth connection, follow it, so figure out the channel map, the hopping sequence for it, the hop increment, and the access address, the hop interval, and things like that. And once you figured out all these different connection parameters, you could jam an existing connection, force a reestablishment of a new connection, and from that point, if you knew the say the long-term key for encryption based on cracking a previous pairing attempt, since at the time Bluetooth 4.2's more secure pairing didn't exist. So you could then derive the session-specific encryption key and then break all subsequent communication. So bits and pieces of this attack were implemented within the Ubertooth. It was not put all together. And also the implementation within Ubertooth for Jamming, I think it wasn't fully fledged for dealing with connections that had channel maps in place that were excluding certain channels. And I remember there being various limitations in the current implementation of the Ubuntu firmware at the time. So I wanted to make a practical attack extending the firmware of the Ubuntu to be reliable in real-world connections that had additional changes to connection parameters.
So if memory serves, I don't remember if this was like during our episodes with Mike or not, but I think it it came down to if you were very lucky, like I think it's like you needed more antennas to capture all of that in one go, and so it was so rare to be able to capture all those bits and pieces, but it was possible.
So the trick was that I was trying to do it with just one antenna, but I just using lots of clever software tricks to figure out the hop sequence just by sampling all the different channels going one at a time, capturing a bunch of data. Then I made some Python scripts that analyzed what I captured to figure out what the actual parameters were in place, doing some process of elimination. Again, it was years ago, and I don't remember the specifics of how it worked, but that was the basic idea.
The beginnings.
So a small needle in a haystack. It's just like you need to throw processing power and
to find
and
it.
so on. It's not impossible, but like a normal human is probably not going to be able to do that in a reasonable amount of time before it becomes obsolete.
Yeah, I couldn't see all the channels at once, but if I just sniffed one channel at a time and got through all the channels and saw something on each channel, I could figure out what possible combination of parameters would result in the observations I captured.
I remember Mike was like, "Oh well, if you get three Ubertooths, then you can cover all 3 advertising channels and then do more things."
Oh yeah, that's actually something I'll get into with what Sniffle did, as that was another little trick I implemented Sniffle to greatly improve reliability compared to past Sniffle. But we'll get there.
So yeah, let's talk about Sniffle, because that was your presentation at Hardware I/O 2019, right? The first time you presented there, I think, for Sniffle.
Yes.
So can you tell us what is Sniffle and what does it do and how does it do it?
And why does it do it?
Sure. So
maybe why Sniffle?
At the time, there were many existing Bluetooth sniffers. I think the main ones at the time when I was creating Sniffle were the Ubertooth, which was open source and probably the most flexible of the bunch. And then there were proprietary sniffers by Texas Instruments and Nordic using their respective development kits. And then there were commercial sniffers like the Elysis system. So with the high-end commercial sniffers made by companies like Elysis, you could use software-defined radio to capture all the channels, or at least have, say, 3 radios running at once to capture the 3 advertising channels. But the Elysis systems were quite complex and expensive, in part because the hardware they required. And these low-cost systems, because they only listened to one advertising channel at a time, you only had a roughly 1/3, or in practice less than 1/3 chance of capturing connection establishment. So that was one of the reasons I went about this. Also, around that time, Bluetooth 5 had come out, and Bluetooth 5 introduced a whole bunch of new features. So one was the new PHY modes for long-range PHY, which has an error-correcting code in place to deal with data corruption over long-distance transfers, and also a high bitrate PHY mode that later enabled the new LE audio functionality. So none of these existing sniffers at the time had support for the Bluetooth 5 features, and all the cheap sniffers only could sniff one channel, advertising channel at a time. And on top of that, with the Ubertooth in particular, which was the only open source sniffer available at the time, one of its limitations was that just due to the way it was implemented using general purpose hardware that wasn't perfectly tuned for capturing BLE, purpose-built BLE hardware that's been tuned by a company like Texas Instruments can have considerably better performance, reliability, and data capture, particularly with so-so signal strength. So I found with purpose-built or hardware that was tuned for use with BLE, I could get much more reliable packet capture, and coupled with some new features I could implement in Sniffle, I could get much more reliable connection detection.
So you're saying that because the vendor hardware like TI, and I'm assuming also Nordic,
Yep.
because you could basically take those and then write software around them to control them to get you have the best of both worlds. You have the great antenna and RF characteristics that you need to capture all the data, and then you can write everything that you need to basically gather all the data, as opposed to what you were talking about, the commercial packet sniffers, which are kind of closed off and you don't have a lot of options. Was that pretty much what you were
Exactly.
getting at?
That's it. I was using the well-tuned radio hardware that was in the TI, and Nordic has similar radio performance. So I was using the well-tuned radio hardware together with my own firmware running on this thing to have the full control I wanted to be able to implement clever tricks to get nice, reliable sniffing and support for new features uh, while still using good, reliable hardware.
Yeah. So I think it's kind of funny because when we're comparing these kits, like the TI kit, maybe you got it for free, maybe you didn't. I think in general all those kits in that time period were under $100.
Yeah, they were
But
quite
then
cheap.
you get the commercial one. The commercial ones, the last time I bought them, $30,000.
Exactly. So those were completely out of reach to hobbyists for the commercial sniffer systems. And I wanted something that had power comparable to these commercial sniffers, but using cheap hardware.
And is the main difference with the Ubertooth? I don't know exactly how it worked, but I remember the Yardstick one, which kind of predecessor. It's doing kind of bit by bit. It's almost an SDR with a CC1101, I think.
Yes.
So is the Ubertooth similar to that, where it's actually decoding the ones and zeros itself, or is it actually using a hardware Bluetooth or hardware radio decoder?
It was very similar to the older ones. So it had a separate discrete radio chip, the TI CC2400, and that's kind of like an SDR. Now you tell it, tune to this frequency, I want this kind of modulation, and it just gives you a demodulated bit stream. And from that demodulated bit stream, you do whatever you want. But because of the way it works, it was a little bit trickier to get the reliable radio performance you wanted. For Bluetooth, there's more things you could do with more sophisticated radio hardware that TI was able to tune. So TI, for example, they, for the most part, got out of making these type of radio chips. Yeah. So with the following generations, the CC25XX and then later the CC26XX family, they switched to having a microcontroller and the radio hardware integrated on one chip, and they had a separate radio core with some ROM-based firmware that would do some low-level radio operations, and then pass up captured frames to the software you had control of. But while that architecture is a bit less flexible, they do give you enough power to configure things that, for my own purposes, I had all the low-level controls I needed to sniff Bluetooth pretty well.
Nice. Yeah, because I guess all you want to capture is a Bluetooth frame. You don't care if it's like addressed to you or not. Like, as long as you don't have to put on all that. But then you don't have to decode preambles or any. I don't know if there's any preambles, but things like that.
There's a preamble and then there's an access address and all that. But some of the tricks have to do with so the access address acts as a sort of sync word, and then the preamble, there's just a bunch of well, actually I think they have, I forgot the terminology for this, but there's usually a long run of just alternating 1-0 symbols, and then you get your access address after that.
Some clock synchronization dealio.
Yeah, yes. The synchronization for the bit rate.
Yeah, so just there are certain tricks to reliable detection. You can also have You can have situations when you have one, two transmitters transmitting around the same time, and dealing with that can get a little bit trickier with the radio tuning. So just overall, I found that I'm not a radio tuning expert, but I found in my own experience that the reliability I could get out of the pre-tuned BLE radio hardware in these newer TI kits was better than what could be achieved with the more general purpose hardware in the CC2400 that the Ubertooth used.
And so what were you able to do? What did this new tool or Sniffle allow you to do that you were unable to do with Ubertooth before?
So some of the things I implemented could have been implemented in the Ubertooth firmware if I extended the Ubertooth firmware, but I wanted to use newer hardware because it was one, it was better tuned for Bluetooth capture, and secondly, the newer hardware I was using, the TI CC2652, its hardware was capable of supporting new PHY modes in Bluetooth 5.
Oh, that's right. Yes.
So the 2 megabit mode and the long range mode. The long range mode's actually just using the same 1 megabit PHY, but adding error correcting codes on top. So it may be possible to implement the old PHY, well, the long range PHY on the Ubertooth hardware, but the 2 megabit mode, the radio hardware just physically did not support it in the Ubertooth.
Right.
So kind of going back, I think we're getting a little ahead of ourselves on this one, but I just wanted to ask before the thought leaves me.
Sure.
So with the long range in particular, did you feel like that was going to be essential for exploring some of the applications you were thinking about doing?
It's still a bit of a niche, the long range PHY, but the 2 megabit mode is very commonly used. The 2 megabit mode, most devices, if they support Bluetooth 5, and both sides indicate they support it, they'll just switch to that new mode. Yeah. And these older sniffers that didn't support that mode would just not be able to capture the connections.
Yeah.
So 2 megabit was certainly essential for, particularly nowadays, as Bluetooth 5 is now becoming quite common.
Yeah. Yeah. I'm mostly thinking about it in terms of not only just audio streaming, but I'm thinking about car locks and things that generally are assumed to be long range. I know that some TV remotes are starting to go that way. So
yeah, the long range PHY I think is most commonly used for, say, IoT application or sensors around your house, or so you can also use it for, say, mesh networking systems where you need to deal with communication over a few hundred meters.
I'm sorry for the podcast listeners, but I'm going to show this is one of my Bluetooth boards that looks like a cheese wedge, and I used the NRF52 11, I think, because it had the LE or the coded PHY.
Wait, go ahead.
Yeah, it's a circuit board for making cheese, and it's got Bluetooth, and I wanted the reliability.
I'm gonna add, this is actually a question not for our guest, but instead for Alvaro.
Sorry.
Were you trying to monitor your cheese from afar? Is that a concern?
Well, for making cheese, for the aging. So I was measuring temperature and humidity in the cheese cave remotely. Yes.
I've seen you. I could see your apartment here. Where is the cheese cave? And is it located? It's 30 feet away. I feel like you might have over-engineered. Maybe
it's all part of the fun.
Okay. Okay. Back to our guest, Sultan.
Is your cheese cave a poorly designed Faraday cage?
Yes, that's what I was wondering too.
It's got a good old glass window. But actually, at my old apartment, I did try them on regular fridge, and Bluetooth still makes it out. I think just the gasket on the door is enough to not make a seal.
Yeah.
I have follow-up questions here. In the future, when you're going to do serious long-range testing of your cheese cave, are you going to approach it from a Batman perspective? I.e., a cave underground.
Oh, wow.
That's vacuous. That's actually going to provide...
Yes. If I could afford it, I'll have an actual bat cave with cheese. Okay.
There's a chance, your company could do really well. I'm just saying. Okay.
Maybe.
There's thumbs up. Audience, there's thumbs up going all around here. Okay, we've gone way off the rails.
So
okay.
Sorry about that.
I regret asking the question.
I got excited about long-range Bluetooth.
Okay. I'm excited, and I will have questions for both of you later. Okay. Where were we?
So I do have a question about both the long range and the high speed or the 2 megabit rate.
Yeah.
Do you know if the pairing still happens to the original and then they upgrade, or do they start at the higher data rate?
So it depends on if the connection is being established using the so-called legacy advertising or the new extended advertising.
Oh.
So if you're using Bluetooth 5 style extended advertising, then the extended advertisements can happen on an alternate PHY mode, like the 2 megabit mode or the long range mode. And if the connection started using an advertisement in the extended Bluetooth 5 mode, then the connection will start on the same PHY mode that the advertisement was sent.
Makes sense.
Whereas if you're starting off in the legacy Bluetooth 4 style advertising, then it always starts off your connection using the 1 megabit mode. Then if both sides say we support this better PHY mode, then we'll switch to it.
Okay, yeah, that makes sense. So you need to have the ability to upgrade, even if you can sniff the legacy pairing, they might switch later. Yeah. Right. Cool.
Just give me a moment. It seems someone's at my door.
Yeah, right. No, of course.
Hey, we're back after just a little brief interlude, but we're just going to pick up right where we were. So we were talking about Sniffle, and you were discussing how, why this one, what were the big advantages, what was it happening in the other software that was available that necessitated Sniffle.
And yeah, so we've talked about the different PHY, kind of like the high bit rate and then the long range encoding. So now you've developed this. Actually, I didn't ask. Is it just firmware in Python? What's?
So there were two pieces to it. Sniffle consists of firmware for the running on the TI CC26X2 family of microcontrollers, coupled with some Python host side code that will interact with the firmware, send it commands to configure it, and then generate PCAPs, display stuff on screen, and so on.
And okay, so now you've have this new tool. How did you start using it? What were some fun projects you've worked on with Sniffle?
So for the most part, I've used it for client projects, and while I can't say specifically what they were, in general, when you have any Bluetooth devices communicating with one another, it's just nice to be able to tell what the protocol between these devices is. It could be any sort of IoT sensor. Quite often, BLE is used for provisioning processes for all sorts of IoT devices where your phone will initially communicate with the device over BLE, give it some credentials maybe to get onto Wi-Fi, and then once it's on Wi-Fi, then you could communicate with their cloud service or whatever. But quite often these initial setup flows where the devices communicate with each other over BLE is pretty interesting from a security standpoint. The other application of this, aside from security testing, is just debugging of devices. So if you have BLE devices that just aren't getting along with each other, by being able to sniff at a low level, you can quickly figure out what's going wrong here and what's triggering a disconnect between devices. Because when you have a bug, let's say inside a Bluetooth controller or in embedded devices that are using like the Nordic chips or TI chips, they don't have a discrete Bluetooth controller. They're sort of a Bluetooth controller and application in one device. When you have some sort of bug in the firmware that's triggering violation of the Bluetooth standard, being able to sniff what's happening over the air is the most reliable way to see what's happening. Because if you're trying to capture data at a higher level of the stack, then you can miss out what's things that are going wrong at lower levels.
And so you capture the packets. Are you generating a PCAP file, or how do you analyze it after the fact?
So initially Sniffle did two things. One was generate a PCAP file you could open in Wireshark, and the other is that I had some basic Bluetooth dissection implemented just for the command line, so you could see on the command line what the data is as well. More recently, I had some contributors provide implement Sniffles support as a Wireshark plugin, so you could just directly from Wireshark invoke Sniffle and then have the data directly stream into a PCAP file in Wireshark in real time rather than doing it through the command line. Depending on what you prefer doing, what your workflow is, it may be more convenient to have it just go direct into Wireshark.
Yeah, it seems super easy. That's nice that people just work on these things, right? Open source.
Yeah.
Awesome. All right, so we've done all the VLE sniffing. But one of the things, I guess, when I Googled you and read a little bit about you, some fun articles came up with kind of relay attacks. So can you tell us a little bit about what relay attack is and what are some of the uses you've had for them?
Sure. So relay attacks are most commonly used to defeat what are called proximity authentication systems, where you have two devices where if you, let's say, have one device in your possession, you walk up to another device. By having some device in your possession that's trusted by the other device, it will let you unlock that other device and do things with it. So one of the canonical examples of this is passive entry in cars. So you can keep a key fob in your pocket, you walk up to a car, you touch the door handle, it unlocks, and if you start it without sticking your key in anything. So what a relay attack does is it makes these two devices think they're close to each other by forwarding communications between these two devices. This can be done by signal amplification, or it can be done by, say, capturing the digital packets coming out of either side and just forwarding them out to the other and transmitting them near the other device. The end result of this is that because the two devices can communicate with each other and the signal strength seems like it's normal, the two devices think they're close to each other, even when in reality they may be some distance apart.
Okay. Yeah, that makes sense. I certainly know the car use case, and I know some apartments or like some door locks will also just unlock, which freaks me out because I rather have to put in something. So it's as simple as that, basically. In many cases, just, hey, I'm gonna forward the signal over, and I guess I've heard cases, right, where somebody leaves their car keys near the front door of their house, and then you can just walk up to the front door and then basically amplify the signal to the car, and then the car's like, oh, you're right next to me, let me open up for you.
Yep, I've had several friends who've had their own car stolen through relay attacks. It's a pretty mainstream thing. And people have been doing it for a long time. There's nothing new about the concept of relay attack, but my research was into ways into doing relay attacks more effectively with lethal energy.
Did you find anything in your research that maybe could prevent or deter these relay attacks?
Yes, so there has been a lot of effort in recent times going into developing what are called secure ranging schemes. And generally, these schemes combine some sort of time of flight measurement with a cryptographic challenge response scheme. And right now, the most widespread form of this is using ultra wideband with the 802.15.4z standard. With these type of schemes, they're designed to be really resistant because they're measuring the time it takes for a signal to propagate at the speed of light, and basically, if you're doing a challenge response type operation, you're measuring how long the signal takes to get across at the speed of light. You simply cannot relay it further without violating basic laws of physics. Now, this is not to say these schemes are completely foolproof. In implementation, you can get little details you could do a little bit of trickery with. And so there have been in recent times some published research that can, to a limited extent, fool the distance measurements estimated through these secure ranging schemes. But nevertheless, they are much more difficult to conduct these attacks than just doing a simple relay. And you cannot do these type of range extension attacks over massive distances the way you could relay communications.
I guess I have a naive follow-up question because I am not as well versed on Bluetooth and what it can and can't do. But I was under the impression that, at least earlier versions of Bluetooth, that not really useful for, to do location. Well, not doing accurate location and therefore like angle of arrival and things like that just weren't pragmatic. Is that no longer true with Bluetooth 5 or subsequent versions?
Sort of. Yeah, in recent versions of Bluetooth, there's been work going into, for instance, angle of arrival determination through multiple antennas and looking at phase differences and how the signal's coming in. But the key difference, so right now, most systems I see doing Bluetooth-based proximity are only looking at RSSI. Many of them aren't even looking at angle of arrival. But,
oh, wow.
But that's not even considered accurate.
Yeah.
Still.
So even if you have angle of arrival measurement, that can be useful for estimating location of something, but that doesn't give you a secure ranging scheme. Because what you could do and what my attack does is that you could just transmit from the same physical location that a legitimate key fob or phone, whatever it would be, from. So from the perspective of the car, door lock, or whatever you're unlocking, the direction the signal comes from and the strength of the signal looks identical to normal operation. So you really need a secure ranging scheme with time of flight and cryptographic challenge response working together to be able to defend against relay attacks.
Yeah, and I guess let me see if I can clarify a bit for the audience. But you can have the most secure key exchange, right? Like you have the best crypto in your phone, and then on the thing you want to unlock. So when it's close, it can do super secure key exchange. But maybe you're at work, and then you left your car at home, and then somebody comes to you next to you at work, and then their kind of their evil partner is next to your car, and then they have these devices. They listen to your phone, forward it over the net to where your car is, and then connect. This is what the ranging check would defeat, right? Because then all the latency would not, the packets going back and forth would take too long.
It would be suspect.
Yeah, a little bit.
Highly, but you definitely need at least two people, though.
Yeah, I guess with amplification, you could probably do it a little bit more quickly, right?
Yeah. One of the other defenses, this isn't foolproof, but if you are making use of sensors like accelerometers in your key fob or phone or whatever, what you could do to defend against relay attack is if you detect your device as being stationary for a long period of time, then it's probably not in the person's pocket. You can disable proximity off. So I know some automakers, for example, have implemented this within their key fobs, and that mostly solves the attack where you left your keys on the table in front of your door at your house.
That probably saves power too.
Yes.
Win-win. That makes sense.
So like a wake on motion-y type of thing.
Exactly.
Yeah. I think the thing that's so interesting is listening to this is because at this point, what really is the difference between your key fob and, let's say, a tile or an AirTag, which will have some amount of like ultra wideband in it, perhaps, to like do more accurate ranging and in location. But obviously, that would just eat up that battery like so quick. People would actually really need to know how to change the batteries on their remotes, I guess.
Yeah, and I guess we should say that for a lot of cars, it's not Bluetooth, right? It's probably some other protocol.
Yes, usually there are some proprietary RF using lower frequencies. Nowadays, we have started to see some cars that use Bluetooth even with their key fobs, but it's still it's a new upcoming thing. I think over the long term, a lot of companies will adopt the new Car Connectivity Consortium's Digital Key 3 standard, which combines Bluetooth Low Energy for data exchange with ultra wideband for ranging.
Oh, cool. So they're thinking about it.
So this is, at least for the most part, a solution to relay attacks. There are still some attacks that have been developed against ultra wideband that can do some degree of distance manipulation, but nevertheless, it's still much more secure and at least no longer vulnerable to the old-fashioned relay attacks.
And you can combine it with kind of the key fob motion detection and things like that.
Yes.
Very cool. And I guess you've also had success doing this with non-car targets, more like electronic door locks, I guess?
Yeah. Yeah, I've tested this against a few smart locks, including some of the Kwikset and Wiser ones that are very popular, the Kivo line. In those, they have implemented some degree of disabling things when the phone's been stationary for quite a while. The reliability of that feature seemed a bit flaky to me. And then the other thing is that even when you have the accelerometer thing, you could still have an attack. Let's say, you're walking down the street in town and you're not at your house. That still gives a window of opportunity to attack. But nonetheless, the looking at accelerometer readings does at least reduce windows of opportunity.
And in cases like this, where either a customer or you say like, "Hey, I wonder if a relay attack works in device XYZ," what's the process of trying it? Is it as simple as just like, "Hey, let me see what is this transmitting and forward it along," or is it a lot more involved?
It's pretty much that, and we've actually done work for a lot of different clients testing their devices to see if we can relay them, and thus far, everything we've tried the relay attack against has worked. But the caveat to that is that the Bluetooth specification does give a lot of room for interpretation on how you can do things. And so as I've kept trying my relay against all sorts of different targets, I find different quirks in the Bluetooth spec. And so sometimes I may need to make a few little modifications to the relay tool to make sure I comply with those quirks in the spec. But nonetheless, basically anything that relies on just being able to have a BLE connection for proximity off can be relayed.
Wow. Yeah, I mean, that's terrifying. But what I am glad to see is that people are asking you to test their products, themselves, instead of like, "Hey, I have this door lock in my house. I wonder," because as a customer, you can't do that much.
See, this is what always frightens me about like zombie apocalypses, is like I'm always afraid the zombies are going to be smart and fast and that they will figure
they'll have relay attacks.
There's just one reverse engineer that got turned into a zombie and he's just shambling about with his like laptop unlocking people's
You need
stuff.
2 zombies for a relay attack.
You do need 2 zombies for a relay.
It's easier with 2. So, and I guess this was the topic of your presentation at Hardware.io?
Yes.
So yeah, go ahead.
In particular, so the concept of relay attacks been around for a long time, and for BLE as well. But what was different in what I did was conducting the relay attack at a lower level of the Bluetooth stack.
Oh.
And what that allowed achieving was 2 main things. One was I was able to reduce the added latency of the attack, or in many cases, hide the added latency altogether. So from the perspective of both devices, just due to some quirks of how Bluetooth works and when you're allowed to transmit, the latency added was invisible to them, and to them it looked like the added latency of the connection was the same. And the other thing was that by relaying at a lower level of the protocol stack, I was able to relay connections that were employing link layer encryption, whereas past implementations of the relay attack, because they were operating a higher level of the stack that required decrypted data to be able to pass decrypted data to be able to process and forward the data that they're handling, and they were using off-the-shelf Bluetooth controller chips that needed to know link keys to follow the connections.
Mm-hmm.
Because I was doing the relaying at a lower level, I could just forward the encrypted communications and never mind the upper levels of the stack being able to understand what's being sent back and forth.
And since it is encrypted, I guess how do you know which one to forward, I guess, is the question. Like, is it just MAC address, or how do you?
So I forward based on the what's called the access address in Bluetooth, which is so during connection establishment, the initiator of the connection will just pick a random 32-bit number and say that we should use this as a sync word for all our packets passed to each other. So once I know, so I start off by identifying the MAC address of the device I want to clone. You can do that by just scanning.
Yeah.
Once you've identified the MAC address of the device you want to be mimicking on the other side, I capture that device's advertisements and then replay them on the other side. Afterwards, once I get an incoming connection from my device spoofing the advertisement's MAC address of the legitimate device, I'll initiate a connection on the other side, and I'll know the access addresses of the connection. So I will only forward link layer PDUs whose access address matches the connection of interest.
Cool. No, that makes sense. It's just it's such a complex thing. Like there's so many layers, encryption in different places.
Yeah.
Awesome. And I guess it's not up yet, but I know the Hard Radio folks usually publish the videos. So we'll post a link to it whenever it shows up.
Yeah, usually we'll post the slides as well, so we'll give them the slides so they can have those too. It was a bit of a challenge squeezing it all into the presentation, so maybe at some point I'll do a paper or something explaining this in a little more detail. There's a lot of subtlety to how to make things actually work.
Very cool.
Kind of going along with that, feeling rushed and trying to pack it all in. Did you do a live demo?
So,
did you bring a car?
I did not get around to bringing a car to hardware.io, so I just played a demo I recorded at our office. So I've done live demos of this attack before. For example, with the Donut Media folks in LA, I did a live demo for them where they used this attack to essentially, it's steal a Tesla they legitimately rented. But
that's awesome.
But it works quite reliably, this attack. It's not a flaky thing anyway, because I have so much latency margin since I'm just mimicking. Since I'm able to hide the latency my attack adds, and the communication latency looks, from the car's perspective, unmodified from normal operation, actually from the phone's perspective as well. So prior relay attacks, in the case of Tesla, for example, they weren't actually using BLE link layer encryption. So it's actually possible to use some prior relays with those Teslas, but because the prior relay attack implementations that were operating the higher level of the stack did not have the control over low-level timing parameters and had to go through all layers of the stack, they added a detectable amount of latency, and that amount of latency they were adding was enough to kind of push it near the threshold of what the car tolerates.
Yeah.
And it was pretty flaky relaying with that added latency, whereas because I have no visible added latency to the relaying, it's pretty much as reliable as using the phone normally.
That's really cool.
Yeah, I kind of have like a side idea. At this point, we have at least 2 Bluetooth experts, so they could tag team to get into the Tesla. Then we have another person that could probably fix their autopilot.
Oh yeah, we interviewed someone from Comma.
Oh, nice.
Yeah,
we could probably really do a nice overhaul.
I mean, the guests we've had are exceptional. So okay, so moving on to, I guess Jen added one of these questions here. So do you have a favorite Bluetooth chip to work with?
I think the TI family, mainly out of familiarity. I've been dealing with these chips for a very long time. I know their ins and outs, and I've been using TI things a long time. So I think I chose them mainly out of comfort. Both the Nordic NRF52 line and the TI the CC26X2 line do largely the same thing. I think some of the newer Nordic chips are slightly more energy efficient, but it's not a huge difference.
Yeah.
Overall, I mean, the chips do largely the same thing. I just use what I'm used to.
No, it makes sense. All right. There was one other project I saw that looked interesting. That's I don't know how to pronounce it. Nobex and Obex.
Yeah, I just call it Nobex usually.
So yeah, what is that?
So this started off as a fork of Pi Obex by David Boddy, and the goal was for testing infotainment systems in cars by mimicking a cell phone and then feeding malformed data to these infotainment systems for fuzzing them and finding bugs.
Yeah.
So this is Nobex, at least the public part of it is, my main goal for it was to emulate a phone using the phone book access profile and the hands-free profile. And so you could pair a computer running Nobex with your car the same way you would pair a normal phone. Then you could feed it malformed OBEX data, like malformed contacts, and you could send malformed AT commands over the hands-free profile and try to trigger bugs in the infotainment unit.
Very cool. So I had it backwards in my head. So this is to fuzz the infotainment system as if you were a malicious phone.
Yes, but it can also do the opposite.
Oh, it can.
So yes, so you could also fuzz the phone side of things. It implements both the client and server roles for most of the major OBEX profiles. For cars, the ones that were of maximum interest were the phone book access profile, the message access profile for text messages, and then the hands-free profile, which is used for telephony.
Yeah, because I don't know if anyone's run into this. I don't have a car anymore, but so I have to rent cars all the time. And it's always very annoying when you pair a car, your phone to a car, and then it's like, hey, let me take all your contacts. It's like, no, no. I think the newer iOS lets you block it, but early on, yes, you pair your phone just to listen to music, and then you see your contacts on the screen. And I was like, wait a second, like, no, thank you.
Yeah, it's pretty terrible.
I don't even bother trying to pair when it's a rental car. That's how infrequent that happens. Because then you have to do like the delete everything.
I know, but like driving for a few hours without like music, it's ugh.
You can just play the music from the phone, right? It's not
in a car. Same. That sounds so bad.
Oh my god, dude.
Anyway, so one question we ask all of our guests is, what's your favorite tool? And this can be, you could say more than one, but it doesn't have to be reverse engineering related, but it may be. What's one of these tools that they use all the time that people should know about?
Well, I guess one pair I use all the time is so super basic, but Vim and grep.
Hey, grep.
I live in Vim and grep. That's, I mean, as a consultant, a huge part of what I do is code review. And I've gotten adept at using grep efficiently. So sometimes people complain that grep is slow when you use, I don't know, the Silver Searcher or one of those other fancy schmancy new code search tools. But if you use GNU grep with just the right options, it's actually pretty darn quick. And what's so nice is that even if I'm asked to do code review on some isolated box I have to SSH into from another box I SSH'd into, and I have no control what's on it, I can almost always expect it'll have VI or Vim and grep on it.
Yeah, so that's true.
Being comfortable with these familiar tools makes it easy to do my job, even on unfamiliar machines.
So let's be honest. Nobody's reading the man pages anymore because they're impossible to read. So, as a way to lure people into trying out grep for themselves if they haven't seen the magic of grep, what's your favorite flags to use with grep
to
like get the most out of it?
More niche.
This is very niche. Yeah. I'm always curious to hear what flags people are using to like.
So, for me, I use an alias where I called it grip.
Grip. Okay.
Yeah. So grip is an alias for grep dash lowercase r, lowercase n, capital I, and the dash exclude dir equals .git or something like that.
Oh yeah, that's a good one.
So that's recursive grep, include line numbers, only have text files, ignore binary files. It does some heuristics try to figure out if it's code or something. Yeah. Or some binary, and then just exclude the .git so I don't get garbage from there.
Yeah. Oh, that's
I just generally do dash RNI, not capital I. So that's interesting. Okay.
Yeah, the lowercase I use sometimes if I want the case insensitivity, but other times I have seen code bases that have functions with the same name but different capitalizations.
Yep.
Because their code style is super weird. Yep.
Yeah, I know.
But this is a variable for the callback, but this is the actual the actual function name. So yeah, I don't know if they say it like that, but yeah. Was there anything else that we wanted to ask?
I think we covered all the Bluetooth stuff, and we covered the Mike Ryan. So
we confirmed that. I don't know. Was that an important thing to do?
I was going to ask.
Yeah, I've collaborated with him. So with the PCAP format that's used by Sniffle, I think it was pioneered by Mike Ryan for use with the Ubertooth.
Yeah.
Oh, cool.
And at the time, that PCAP format was designed mainly for Bluetooth 4.0. At the time, it didn't have all the new Bluetooth 5 features, but still advertising and new PHY modes, etc. And also, at the time, I think that's still the case that the Ubertooth firmware does not distinguish or identify the direction of packets. So there was no flag within the original PCAP format to indicate the direction of packets. So actually, I collaborated with Mike Ryan last year, I think, or the year before that, sometime around then, to extend the definition for the Bluetooth LE link layer PCAP format to include all the new features of Bluetooth 5.
Nice.
Awesome.
Let's see. What else do we have here? I guess we're gonna close out the show, and
yeah,
Alvaro's gonna edit out just what I just said. Any parting words from our guest? Any deep thoughts, or not deep thoughts? No stress.
In general, this is not even specific to this research of mine, but in general, things that a lot of people don't look at are usually very broken. As long as you go slightly outside well-trodden paths, it's amazing what kind of bugs you encounter in very popular mainstream systems. And it's also interesting how makers of products can have pretty nonchalant attitudes to pretty serious risks facing their products.
Yep.
So, yeah, the world of security is a little scary.
Or exciting.
That's good. It depends which side you're on, yeah. Hey, job security for you.
Okay, now then, we have some housekeeping here. If you guys listened to the previous episode, we said that we were going to make a shirt. Well, we did it. But more importantly, we're making it easy for you guys to do your holiday shopping, even if it's just for yourself. So we're selling them at cost until Cyber Monday. That's 11/28, 2002. No, 2022. Oh my God, I time traveled. Find the details in these show notes, or on our Twitter account, or even our YouTube channel. Which kind of brings us to the next point. Do you have comments or suggestions for names for the show, even though we're kind of past that now at 5 years? You can find us on Twitter at unnamed_show, or on YouTube, because we finally got our handle, at unnamed RE show. Or you can hit us up at the comment form, which we will never look at. If you still can't find us, you can go to unnamedre.com. And Alvaro, where can people find you?
I'm alvarop.com or at alvaropeta on Twitter. Oh, where can people find you online?
I guess the easiest way to find me is on GitHub. I'm not much of a social media person, but...
Okay, GitHub. All right.
Yes, obviously the GitHub, which will be in the show notes. Yes. And then you can find me at RebelBotGen on Twitter. We do have new Patreon supporters since the last time that we did anything, and that includes Thomas, Kestrel, Simon, Mark, Scott, John, Lachlan, Drew, Joseph. I think that's since the last time.
All right.
And I think that is actually it. Unless you want to review the show, audience. I think we're going to get a bad review from Sultan. Also, we should give a bad review for Zencaster.
Thank you so much for joining us, Sultan.